Hi there, I'm Dr. Yvonne and I teach CME319 Biochemistry. In biochemistry, we are going to learn a variety of different biomolecules ranging from carbohydrates to proteins to lipids, and we're going to learn the processes involved, such as the breaking down of those molecules or the synthesis of those molecules. In the mini lecture series today, I'm going to bring you through Chapter 3, Protein, and more specifically, we'll talk about protein purification. What you're seeing here is milk. Yep, that's right. So in milk, there are mixtures of milk proteins. So milk proteins, let's assume here, there are 3 different proteins that makes up this mixture. We have milk protein A, that causes allergy, so it's bad. And we have milk protein B and C, each being good for you. One obvious thing to note within this slide is the size difference between these 3 proteins. My question to you here is, how do you use biochemistry to remove the bad proteins from the good ones? How do you purify the milk? Now, before we go into the method that would be able to do that, let's bring in Mario Kart as an analogy. Anybody play this game before? Yes? No? Well, this is a racing game, and you get to use traps or set traps to kind of slow people down. So I'm going to use this concept, right? Imagine you're at a racetrack. Start your engines. Now imagine you have 3 different players within the racetrack. The smallest car being the smallest protein, and the largest being the good proteins. Right now, imagine that you can set different complexity tracks for each car or for each protein. You set the simplest track for the larger ones and the most complex track for the smaller ones. Now you put them through a race. On your marks, get set, go! Off they went racing through their respective tracks and see who's leading. You have the green one, then followed by the pink and followed by the blue. But my question to you here is, why? Now let's compare them side by side. We know that the largest protein goes through the simplest path or the shortest path. Then we have the pink one, which goes through the moderate one, and the blue one that goes through a super complex track and the longest among all. So logically speaking, the smallest would come out last. Right now, this method of separating proteins based on its size, it's called gel filtration chromatography. This is a technique whereby proteins are separated based on their size, molecular weights. Larger proteins, because they can't enter pores, they go through the shortest path and they elute first. Elute means come out. The smallest one, on the other hand, goes through the most complex path through all tiny pores. They come out last. So this is how you would define or talk about gel filtration chromatography. There you go. Biochemistry saves the day, and you can now remove bad proteins from the good ones with gel filtration chromatography. I'll see you in class in your 2nd year. Goodbye for now.